Okay, welcome. This is 5.3 Evaluation Theorem. Okay, so we learned about integrals and antiderivatives on 4.7. So today we are still going to find antiderivatives, but now we are going to plug in numbers. So evaluation theorem says if f is a continuous function on some interval a, b, and f, capital F, is any antiderivative of f, then the integral from a to b of f of x dx is equal to the antiderivative, capital F of x, on the interval a to b. When you plug in numbers, it's f of b minus f of a. So it's always top interval minus bottom interval. And you see that there is no c. There's no constant of integration when using evaluation theorem. Okay, so just plug in B, plug in A, boom, good to go. Okay, formula still stands. Power rule, e to the x, 1 over x, constant, addition, subtraction, cosine, sine, secant, all that good stuff. So those are all the formulas from 4.7 that I left on the paper. So let's try it out. Okay, so this one's the integral from 0 to 10, the integral on the interval 0 to 10 of 4 dx. Okay, well 4 is a constant, so this means we get 4x. That is the antiderivative of 4, right? Okay, so the next thing we want to do is evaluate this from 0 to 10. Evaluate from 0 to 10. Okay, well this means that this becomes, 4 times 10 minus 4 times 0. And what we end up with is 40. So the integral from 0 to 10 of 4 dx is 40. Now, of course, you're probably wondering, what did we just find? And what you have just found is the area underneath a given function on an interval, a given curve, a given line, whichever, on an interval, okay? All right, so to show you what I'm talking about, we're going to look at the original function inside the integral, which is 4. So here we go. So inside was y equals 4, right? Y equals 4. And this was on that interval 0 to 10. Okay, so if I were to draw y equals 4, here would be 0, here would be 10, and then here would be 1, 2, 3, 4. So our function would look like this. Okay, well, a little straighter, but whatever, because y equals 4 is a horizontal line, right? So what we are actually doing here is finding the area underneath this line, underneath this function. So we're finding all of this area, right? Which we found to be 40. Well, it kind of makes sense because my graph actually looks like a rectangle once I put all the area in there, which means that this side was 4 and this side was 10. And the area of a rectangle is length times width, or 4 times 10, which is 40. Crazy, right? So that's what we're finding. We are finding the area underneath a given function, a curve, a line on a specific interval. Okay. If you really wanted to get specific on how that 40 came about, well, underneath this line is the sum of an infinite amount of rectangles, which means I'd have a rectangle here, 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 or maybe, well, first, if all these rectangles were about even, the same size, they would equal 40. Or maybe I have multiple smaller rectangles inside this area. No matter what, the sum would be equivalent to 40. The sum of their areas would be 40. Insane. I know. It's crazy. And you can keep drawing more mini rectangles in there. No matter what, you'll still get to 40. So, something to think about in the near future. Cal 2. Okay, moving on. All right, we don't have to draw the graph all the time, but I'll probably do it on this one just to show you what you're finding, right? Okay, so again, we do it, the integral from 0 to 6 of x squared, power rule on this one. This just becomes x cubed over 3 on the interval 0 to 6. Okay, plug it in, and you're gonna have 6 cubed over 3 minus 0 cubed over 3. Which gives me 6 cubed, I believe, is 216 over 3. 0 cubed over 3 is still 0, right? What is 6 cubed? 216. All right. And just divide 216 by 3. You ready for a cool trick really fast? All right. What is 21 divided by 3? That is 7. What is 6 divided by 3? That is 2. What? Fun, right? 72 is our area. Hey, look, I made a heart shape. All right. No. There we go. Okay, beautiful. So 216 divided by 3 is 72. Okay, once again, you're gonna do it one more time, not after that. Just showing you what we found. So let's look at x squared, right? Let's look at y equals x squared on the interval 0 to 6. So again, here's 0, here's 6, and we know that x squared looks like this. X squared looks like that. So when we're at 6 and we're at 0, we are finding the area underneath this given curve. So all of this area underneath here is 72. And again, I could keep drawing rectangles in there, and I would get the sum is 72. Okay. Cool, huh? All right. Always cool. All right. All right. Perfect. Moving on. All right, let's continue. All right. I'll show you another cool trick after this one, okay? All right. So let's go ahead and find the antiderivative of this on the interval 1 to 4. And first thing is power trick on 5x. The 5 stays out, and you get x squared over 2. Plus 3x. You then, that's it, 1 to 4. We will then evaluate from 1 to 4. Okay, let's make it look pretty, and you get 5 halves x squared plus 3x from 1 to 4. Now plug in 4, plug in 1. All right, so I have 5 halves times 4 squared plus 3 times 4 minus, start a parentheses, 5 halves times 1 squared plus 3 times 1. All right, what is that? 5 halves times 16 plus 12 minus 5 halves plus 3. How am I in space? Oh, I'm good. Okay. So 5 halves times 16, that's 2, that's 8, that's 40. That's 40, right? Yep. 40 plus 12 minus this, I'm going to change into decimal. That's just 2.5 plus 3. So 5.5. And then 52 minus 5.5, 46.5. 46.5. Okay, not bad, right? All right, let's save you some time here. So, watch this. All right, now, look at this screen. All right, so this is what we have so far. So, if you have a TI-84 and it has the integral capabilities, your life's about to get a whole lot easier. But remember, on test, you still have to show your work. So you can only do this to check your answer, okay? So I'm gonna do number 3. Watch this. I'm gonna go to math, scroll down to F and integrate. Hit enter and watch, it's magical. Oh, wow. So we're gonna type in 1 to 4 of 5x plus 3 with respect to x. And now all you have to do is hit enter. My goodness, 46.5. Okay, and let's say you have the fancy smancy TI-30X chromed out edition scientific calculator. Well, this means you are in luck because it does the same thing that the graphing calculator does. You go second, find the integral button right there, and do the same thing. 1 to 4 of 5x plus 3, and no matter what, this one always does it with respect to x, and hit enter, and oh boy, 46.5. Okay, let's say that you don't have this integral button. Well, you're still good. Let me go to the regular blue scientific calculator, okay? So, on the regular blue one, let's say you don't have an integral button. It's okay. You're gonna go to the table. Oh, not that. Table. And what I'm gonna type in is the part right after, is the actual antiderivative. Not the integrand, not what's inside the integral, but the antiderivative. So, what I'm gonna highlight in red on the right side is what I'm typing in the calculator. this is going in the calculator into the table feature. So fraction button, 5/2. If you don't have a fraction button, well, 5/2 is just 2.5. X squared plus 3x. Enter, enter, enter. Ask X. Okay. I can clear these, don't need those. And now I'm going to type in the top interval, which is 4. I get 52. I'm going to type in the bottom interval, which is 1, which is 11/2. Or scroll over, change it to 5.5. And just like I did on the paper, 52 minus 5.5, 46.5. Works either way. Okay. And I'll show it on here. Let's say your graphing calculator doesn't have this fancy stuff, right? So I'll do 2.5 x squared plus 3x. Enter. Second window. I need to go down to ask. Enter. Second graph. Now I'm going to do the same. Type in the top interval, 4. Type in the bottom interval, 1. And subtract the 2, 52 minus 5.5, still 46.5. So that's what you have to do. So there you go. Type in the table on the calculator if you don't have these fancy features, right? If you do have these fancy features, then this is what you type in the calculator. What I highlight in green right there. So if you have the features, just type this in calculator. Type in the calculator, but remember, we only do this to prove your work, So type in calculator to prove answer, or to double check your answer. Because what I want to see on the test is all of this worked out still. That's it, okay? All of it worked out. Don't just type it in and give me an answer. You're gonna get points taken off. Okay, excellent. Let's keep moving. I can leave this screen up because I'll use this calculator over here to help me out. Okay. So number 4, this one's straightforward because the integral of e to the x, let me see. There we go. All right, the integral of e to the x is still e to the x. And you will evaluate from 0 to 1. So this will give you e to the first minus e to the 0th, which will give me e minus 1. E minus 1. So this is all the work that needs to be shown. Up until this point, this is when you can actually just type in the answer right here. So let me see. Second integral, not second, oops, math. There's that, and then from 0 to 1 of e to the x. So second, where's natural log? E to the x with respect to x, bam, 1.718. That's it, right there. Okay, perfect. Let's move on. Go to the one below. Maybe I'll zoom in a little bit more for you. There you go. Okay. 5. The integral from 1 to 2 of 1 over x. The antiderivative of 1 over x is the natural log of the absolute value of x. So we're going to get the natural log of the absolute value of x evaluated from 1 to 2. So I'll get natural log of 2 minus natural log of 1. Fair enough. I can type that in here without even have to do the derivative. Or if I can't, there you go. Natural log 2 minus natural log 1, which is just 0. I get 0.693. And again, I can check my work. 1 to 2 of the natural log, not natural log, oops, of 1 over x dx. Boom. Same thing as above, 0.693. Yeehaw, right? Life is good. Didn't know your calculator could do that, huh? All right, let's keep going. Okay, the integral from -2 to 2. I like this calculator better. Just saying. All right. From -2 to 2 of x cubed plus 7x. So power rule on x cubed, which means you're going to get x to the 4th over 4 plus 7 times power rule on x squared over 2. Evaluated from -2 to 2. This becomes 1/4 x to the 4th, 1/4 x to the 4th, plus 7/2 x squared. From -2 to 2. Okay, plug in 2, plug in -2. So here's what I'm going to do. I'm going to show the table work. Builds character, right? So 1/4 or 0.25, whichever you prefer. I can say 0.25 because that's the same as 1/4 x to the 4th plus 7/2, which is 3.5 x squared. Enter, 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 enter. 2. That's the top interval. Always type in the top interval first, because it's always top interval minus bottom interval. So type in 2. I get 18. Minus, type in -2. I get 18. Hey, look at that. This area happens to be 0. Huh. I wonder how that happens. We'd have to look at the function, because this means that the function probably is probably below the x-axis and then above the x-axis on a certain interval. But that's not our worry. Not till Cal 2, that's your worry. But go ahead, graph it, see what you get. Okay, check my work, of course. So quit. I need to go to the fancy calculator. There we go. second integral -2 to 2 of x cubed plus 7x. 0. Look at that. Checks our work. Doesn't do our work, checks our work. Because once again, everything I'm writing on the notes is all the steps I want to see on your exam. All right. Let's keep going. Fun stuff, right? All right. So let's keep going. And now we'll do the integral from 2 to 5 of 2x plus 9. And I think we can all agree that the integral of 2x, no matter what, is always going to be x squared, right? Because if I said, what's the integral of 2x dx? It would be 2 times x squared over 2. And your 2's would always cancel, which leads me to x squared. So if you ever see 2x, the antiderivative is already x squared. All right, plus 9x. Evaluated from 2 to 5. Evaluated from 2 to 5. Okay. All right, so go back to my table, add function, clear. I have x squared plus 9x. Enter. I don't need a second function, keep that blank. Go down, ask x, clear these out. Type in 5, I get 70. Minus, type in 2, I get 22. And 70 minus 22, what is that, 48? And again, check. Second integral 2 to 5, 2x plus 9, 48. Looking good. All right, keep moving. Integral from 2 to 3 of 6 minus x cubed dx. So ready for the antiderivative already. 6x by the constant rule, and then power rule. Negative x to the 4th over 4. From 2 to 3. Make it pretty. And type in your calculator. So table 6x minus 0.25 x to the 4th. Type in 3, get negative 2.25 minus, type in 2, I get 8. We get negative 10 0.25. Okay, and another question that should be popping in your head is, how is the area negative? Oh boy. Again, it all depends on the graph and how you're finding it, right? What would that be? Negative xq. Yeah, I think that all would be negative. Okay, moving on. I'll leave you to ponder it. All right. Oh, I didn't double check my work. One moment, please. 2 to 3 of 6 minus x cubed. Negative 10.25. Yeah. Okay. Moving on. Okay. Come on. There we go. All right. So power rule on this one. So the 2 stays out, and you'll get x to the negative 1 over negative 1 minus 3x. Yeah. And then evaluate from 1, 2. And then this becomes just negative 2x to the negative 1 minus 3x, still evaluated from 1 to 2. Now, let's type in our calculator. All right, table, add, clear, negative 2x to the negative 1 minus 3x. Type in 2, I get negative 7. Minus, type in 1, I get 5. Okay. That'll give me negative 7 plus 5, so negative 2. All right. Let's see what we got. Check my work. Integral from 1 to 2 of 2x to the negative 2 minus 3. Negative 2. There we go. That's it. That's it. All right. Keep moving. 10. All right, before we continue, we know we need to rewrite. So this will be the integral from 1 to 4 of 3x to the 1/2 dx. 3x to the 1/2 dx, and now we're ready for the antiderivative. So this will be 3 times, power rule this, right? 1/2 plus 1, that is 3/2, right? So you'll get x to the 3/2 over 3/2. Evaluate it from 1 to 4. Then flip, and you'll get 3 times 2x to the 3/2 over 3. Still evaluated from 1 to 4. Okay, one final cleanup. 3's cancel, and you get 2x to the 3 halves from 1 to 4. Let's see, if I type in 4, that is the square root of 4, which is 2, and 2 cubed is 8. I think I get 16 minus 1. So I think our answer is 15. I could be wrong. Let's see. Table, add, clear, 2x to the 3 halves, or 1.5. Oh, not 1. Should be 2. Ah, no! 2. There you go. 14. All right. All right. Type in 4. 16. Type in 1. You get 2. Look at that. All right. And of course, check our work. 1 to the 4 of 3 second square root x dx. 14. It's a beautiful thing, right? All right. Hey, 2 left. Whoop, whoop. All right. And of course, they're ugly. Great. What did I do? Okay. So a couple of rewrites here, of course. So the integral from 0 to 1 of x times x to the 1/3 plus x to the 1/4 dx. X times x to the 1/3 plus x times x to the 1/4. And now distribute the x. We get the integral from 0 to 1 of x to the, what's that, 1 3/3 4/3 plus x to the 4/4 plus 1/4 5/4 dx. Okay, we are now ready for the antiderivative, which means power rule. So you'll get, for x to the 4/3, remember you're going to add the 1, so 4/3 plus 1, that's 3/3, so that's 7/3. So this becomes x to the 7/3, ugly 7, over 7/3, plus 5/4 plus 1, which is 4/4, 9/4, right? X to the 9/4 over 9/4. Evaluated from 0 to 1. Flip, flip, flip. Who they want? They want flip, okay? There you go, computer cut up. You're probably like, what is he talking about? All right, now flip both of those fractions and you'll have 3x to the 7/3 over 7 plus 4x to the 9/4 over 9. Still evaluated from 0 to 1. Okay, now time to type this in our calculator. Well, I don't think we have to, though, because if you put in 1, 1 to the 7/3 is still 1. So you would be left with 3/7 plus, same thing, 4/9 minus, if you put in 0, well, 3/7 becomes 0, 4/9 becomes 0, so this thing would just be 0. Which means 3/7 plus 4/9. Eel. Good thing we have a calculator, right? 3/7 plus 4/9. 55 over 63. Or 0.873. Oh, all right, let's check. Because if you were to type this in the calculator, because you don't want to deal with all that by hand, right? I would type this in as 3/7 x to the 7/3 plus 4/9 x to the 9/4. There you go. Enter, 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 enter. And if I type in 1, the top of it, right? I get 55 over 63. And if I type in 0, I get 0. And 55 over 63 minus 0 is what, Tyler? Correct. Just kidding. Tyler's not here, but I was told to give him a shout out. Good job, Tyler. All right. Moving on, right? Because then you can come over here and bam, change that to decimal, whichever works. Okay. Last one. Forever for Cal 1, last lecture. Okay, the integral from 1 to 4 of the square root of y minus y over y squared. All right, so of course we have to manipulate this algebraically, and I think we learned that last time. Just taking y squared and flipping it to the numerator is a lot easier. So the integral from 1 to 4 of y to the -2 times y to the 1/2 minus y. Ooh, and that shouldn't say dx, that should say dy. Let's go, computer, catch up, catch up. Okay, so dy. Okay. Distribute it. And you get the integral from 1 to 4. You distribute that. -2 plus 1/2 is -1.5. So that is y to the -3/2 minus y, and y to the -2 times y is -1 dy. Okay. Almost there because we have to rewrite it one more time. Because y to the -1 has to be rewritten as 1 over y. Okay, we are now ready for the antiderivative. Let me make sure. -2 plus 0.5, -3/2. Perfect. So, power rule on the first one. -3/2 plus 1. 1 is 2 over 2, so you'll get -1/2. You get y to the -1/2 over -1/2, right? -3/2 plus 1, -1/2. Okay. Minus, oh, come on, computer, catch up. Y equal to -1/2 minus the natural log of the absolute value of y from 1 to 4. Any day now, computer. Wow. Okay. Well, you know what's next. Flip. You'll get -2y to the -1/2 minus the natural log of the absolute value of y from 1 to 4. It really doesn't want to catch up. Come on, come on, come on. Do. Make sure to speed this part up, huh? I'll hit pause for a second while we wait. Pause recording. And it's back. Yay. Okay. So that's everything. Minus natural log absolute value of y, 1 to 4. Flip it. It's -2y to the -1/2 minus the natural log of the absolute value of y from 1 to 4. And now plug them in your calculator. But of course, you're going to want to type it in with x, not y. -2x to the -1/2. So I'm just going to do -0.5 minus the natural log, where are you, of x. And enter, 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 enter. Type in 4. I get -2.39. Minus, type in 1, and I get -2. Well, I think that's just going to give me -0.39. Let's see if we're right. See if we're right. Like you're actually here. It's just me and my own doom. All right, what am I going to type in? I'm going to type in the very last integral we set up. So x to the -3/2, so the -1.5 minus 1 over x. Negative 0.39. Would you look at that? Beautiful. Okay. What if I typed in the original, right? 1 to 4 of fraction second square root x minus x over x squared. Negative 0.39. Sweet. That is it. That is evaluation theorem. And I have no more to teach you for now. Okay, that's it. Plug in numbers, check your work with the calculator, do your integrals, and enjoy. All right, guys, that's it.